Assalamualaikum and a very good day to everyone. Today, we are going to present to you a case study about a handling unit, AHU. My name is Nora Ashikin and my partner name is Nur Saida Tanisa Shakila. Let's begin our presentation with executive summary. Our case study aim is to present the air distribution case study findings of the air handling unit, AHU, and its operation in heating, ventilating, and air conditioning HVAC air distribution. And we also provide the introduction and the background of the HVAC air distribution and AHU. So basically, the function of the AHU in a building is used to restore and flow air as a heating, ventilating, and air conditioning system. And the components include a grill, filter, heating and cooling coil, supply and exhaust fan, dampers, pressure sensor, and temperature sensor. Also, in this case study, we will explain the air filtration, types of air filters, and the importance of air filtration. Let's move on to introduction. The definition of AHU stated by American National Standard Institute Standard 430-2009. A factory-made and cast assembled consists of fan and other suitable equipment to perform one or more tasks of circulating, cleaning, heating, cooling, humidifying, dehumidifying, and mixing of air. It is also used to regulate and circulate air as part of HVAC system, and the AHU used to control the space temperature, humidity, air movement, and air cleanliness. In this case study, there are two types of terminal type AHU, which is the first one, small terminal type AHU, are mentioned as fan coil units, FCU, or blower coil units, BCU. It is easy to control and serve a single building zone, for example, loading dock or a stairwell in a large building. Its regular load abilities for FCU are 200 to 1200 CFM, while BCU vary from 400 to 3000 CFM. The second one is large AHUs. It is suitable for outdoor use, placed on grade outside or the rooftop, and commonly referred to as package unit or rooftop units, RTU. The cooling capacity might be stated in heaps, where 1 ton equals to 12,000 British Tamil unit per hour, BTU per H, which with usual function ranging from 3 to 10 tons or more. The next level of AHUs may be semi-custom, flexible but catalog. The custom AHU can be chosen primarily based on any commercial, institutional, or even industrial application. These new units commonly use a building block or modular construction methodology to enable an extensive range of standard and custom engineered modules. Next, background and working principle of AHU. AHU can be found in medium to a large commercial and industrial building. It is usually located in the basement, on the roof, or the floors of the building. It serves a specified area or single purpose. All high-rise buildings would have one large AHU, usually located on the roof, but don't have a return duct. It is common to have multiple smaller AHU supplying different zones to give better controls and high-quality space conditioning. Buildings are now much more airtight, so we need a return duct to regulate the building's pressure. As we can see here, this is the diagram of the air handling unit housing. The working principle. The AHU have two housing, which is the first one here is the return air, and this one is the flow air housing. I will explain the return air housing first. Okay, the return air from the building will enter here and will discharge the return air to the atmosphere. As for the supply air housing, the fresh ambient air take will pull through by the AHU and supply conditioned air to building. In order to recover energy in the AHU, there are four types of design of AHU that we can use to recover energy. The first one is run around coil AHU. coil in both AHUs are used and pump circulates water between the two coils. It will pick up the waste heat from the extract AHU and add to the supply AHU. It will reduce the heating demand on the heating coil when the outside temperature is below the supply set point temperature and when the return air temperature is higher than the set point. The second one is mixed air dual duct AHU. This is the what we call it, the example of the mixed air dual duct AHU. It allows some of the exhaust air to be circulated back into the fresh air intake to offset the heating and cooling demand. It is safe and healthy to do so, but need to ensure that the exhaust air has a lower CO2 count. So CO2 sensors are required to monitor the CO2 level. Next is the heat wheel AHU. This is the diagram of the heat wheel AHU here. Okay, it is very common in newer compact AHUs. It uses a large rotating wheel. The wheel will rotate, driven by a small induction motor. As it spins, it picks up unwanted heat from the exhaust stream and absorbs it into the wheel materials. The wheel then rotates into the fresh air intake stream, and it is beneficial, but some air will leak from the exhaust into the fresh air stream, so it is not applicable to all buildings. Maybe some part of the building are applicable. And then the last one is air plate heat exchanger AHU. It uses thin sheets of metal to separate two streams, and then the temperature difference between the two streams will cause the heat to transfer over from the hot exhaust stream, metals walls of the heat exchanger, and the cold intake stream. Now I will explain to you the process, equipment, services, system operation in HVAC air distribution. The first object we got here is the grill. The grill is used to prevent objects and wildlife from entering into the mechanical parts inside the AHU. The second component is damper. Here and here, it can vary their position somewhere between the to restrict the amount of air enter and exit the return ductwork and the supply ductwork. So the third and fourth component is filters. The first filter here is the primary filter, and the second one is the secondary filter. The function of the filter is to catch all the dirt, dust, bacteria, etc. from entering the AHU and the buildings. So the fifth and sixth component we got here is the cooling coil and the heating coil. The function of this coil is to heat and cool the air. And this the seventh part is the exhaust fan. Sorry, the supply fan, and the here is exhaust fan. The fan will pull air from the outside and through the dampers, the filter, and also coil, then push the air through the ductwork and flow it through the buildings. This is the definition for the supply fan. But for the exhaust fan, it will push back the return air from the building to the atmosphere. So here is the sensor, pressure sensor. The pressure sensor will sense if the fan is running. If the fan is running, then it will create a pressure difference. The sensor may detect a failure in the equipment and warn the engineers of that a problem may occur by sensing the pressure drop. Let's put it here to here. And then the temperature sensor. Temperature sensor will sense the temperature of the air to regulate the required air entering the building. Now I will further explain to you about the primary filter and secondary filter. First, let's start with primary filter. Primary filter can be called as panel filter, works to catch dust. It is made in a pleated design, which increases the surface area and allows it to catch much more dust and last a bit longer. it can catch dust particle down to 4 to 5 microns, but can't catch anything less than 1 or 2 microns. So here is the example of a primary filter or panel filter. Okay, the secondary filter can catch pollen and bacteria and some other particles escape from the primary filters. It is made from synthetic material in the form of a bag filter. So this is the diagram of, the picture of a bag filter type. This bag filter type creates a lot of pressure resistance that the fan has to overcome. The higher efficiency filters will create a lower pressure drop, and the fans can overcome the pressure a lot easier. So the importance of the air filtration is to stop the dust from entering further into the AHU, as it will stick to the fans, the motors, and the cooling coils. Second is to avoid a dirty air supply to the building. That's all from me. I will pass the presentation to Shakila.
Okay, now let's discuss about the calculation part. Okay, firstly, we need to find the point A, point 2, point A1 from the inlet to the outlet. Okay, and then the rate cooling coil, I get Q, which is 396, which is I use this formula Q even equal to MA H1 minus H1A, and then the rate of water dense remove for the system, which is I use this formula and I get the answer, and then the temperature immediately after, which is I got 8 degrees Celsius. I got from the psychometric chart. This is for answer D, which is I sketch the process from the psychometric chart. Okay, for suggestion and recommendations, there are a lot of tips for how keep air conditioning system for function properly. Firstly, clean around outdoor condenser unit for getting most efficient. Next, vacuum indoor vent and keep vent unblocked to help to maintaining system airflow from your systems. Insulate any exposed ductwork, which is for avoid leaking problems, and clean your drain line for saving the basement from taking on water if the drain become blocked. And the last, keep lamp and other heat producing appliance away from your thermostat. Okay, in the discussions, there are a lot of reasons for failure that commonly happens and can be identified, such as dirty filter, improper balance damper, broken thermostat, and the leaking of refrigerants. This is a table that show about the faulting in AHU systems. There are a lot of devices such as fan, ducting heating coil, cooling coil, preheating coil. This is explanation about the typical fault that having in that device. Okay, in the conclusion, AHU is used to recondition and recirculate air as part of a heating, ventilation, and air conditioning system. Based on the weakness of the systems, there are a lot of tips or methods that can help in improving the quality of the systems that consist in recommendation and also the suggestion in the previous slide. By improving the efficiency of the operating systems, it will help all the components will achieve functioning properly. The comfort and indoor air quality of the system provided, as well as for its ability to keep energy bills lower.